Hi students, welcome to chemistry online for first year students. See, in previous class we are discussing isomerism, types of isomerism. First, structural isomerism. How many types means we discussed chain, positional, functional and metamerism. Chain isomerism we discussed in previous class. We continued that in this class we are going to discuss position isomerism. Position isomerism we are going to discuss. What is a position isomerism means? Organic compounds having same molecular formula but different in functional groups. Position of the functional groups are atoms. Different in the position of functional groups are atoms. This phenomenon is called position isomerism. Organic compounds having same molecular formula. Organic compounds having same molecular formula but different in position of functional group or atom is called, this phenomenon is called functional position isomerism. Position isomerism. When two or more compounds having same molecular formula but different in position of atom or functional group is called position isomerism. Okay, so organic compounds having same molecular formula but different in the position of an atom or functional group attached to the carbon atom. So different in the position of an atom or functional group. Okay, this phenomenon is called position isomerism. This phenomenon is called position isomerism, and compounds are called position isomers. See students, I am going to explain with help of example C3H8O. It is the molecular formula. By using this molecular formula, I am going to show variations in organic compound. So first of all, we may write this molecule CH3, CH2, CH2OH. See here 1, 2, 3, C3, 3 plus 2, 5, 5 plus 2, 7, 7 plus 1, 8, H8 and oxygen, it having oxygen. Okay, see here, if you give numbering 1, 2, 3, it is the functional group. It is a functional group. It is alcohol functional group. Alcohol functional group. It is in first position of carbon. So name of this molecule we may write how many carbons? 1, 2, 3. Propane. 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 In the place of E, we may write its position of the functional group. Propane 1 ol. Alcohol functional group means ends with ol. Now I am not going to change its molecular formula. Now I am going to change the position of the functional group only. Then second compound I am going to write CH3 CH3 and OH. C1 C2 C3 3 plus 3 6 plus 2 8 and 1 oxygen. Now I am giving numbering 1 2 3. 3 carbons means propane. The position of the functional group, it is a functional group. Now its position, it is a functional group. Okay, now its position is a second carbon. So we may write its position. How many carbons? 3. 3 means root word is a propane. In the place of E, so we may write propane 2 ol. So here alcohol position is a first carbon and here alcohol position is a second carbon. So the functional group changes its position. A is nothing but a positional isomerism. Organic compound having same molecular formula but different in the position of an atom or functional group. Okay, this phenomenon is called isomerism and the compounds, these two compounds are called positional isomers. Understand, students? Then we go for functional group isomerism. Then this is the second one. It is a second one which is a position isomerism. Then we go for functional group isomerism. Functional group isomerism. So here also you have to know first what is a functional group isomerism. So what is a functional group isomerism? Means organic compounds having same molecular formula. But different in their functional groups. Attached to the carbon atom is called functional group isomerism. Here we are changing, in this one we are changing only position of functional group, but here we are changing total functional group. Okay, organic compounds having same molecular formula but different in its functional group is called functional group isomerism and the compounds are called functional group isomers. Okay, see here, organic compounds having same molecular formula but different in functional groups. This phenomenon is called functional group isomerism. Functional group isomerism. And compounds are called functional group isomers. Example, see, we may say C3H6O. C3H6O. It is the molecular formula. I am going to use this molecular formula to show two functional groups. So first one, CH3, CH2, CHO. C1, C2, C3. C3, 3 plus 2, 5, 5 plus 1, 6 and 1 oxygen. It is aldehyde functional group. Aldehyde functional group. So writing its name, 1, 2, 3. How many carbons? 3 carbons. 3 carbons means root word is propane. Okay, in the place of E we may write its functional group suffix Al, propanol. Okay, so it is a aldehyde functional group in suffix we may write Al, so it is a propanol. Now I am changing its functional group. See here, CH3, C double bond O, CH3. C1, C2, C3, 3 plus 3 hydrogen, 6, 1 carbon, 1 oxygen. So now it is a ketone functional group. Understand? Organic compound having same molecular formula but different in its functional groups. This phenomenon is called functional group isomerism. So here ketone, write its name, give numbering, 1, 2, 3. How many carbons? 3 carbons. 3 carbons means propane. Okay, in the place of E we may write propane 2-one. Understand? Propane 2-one is nothing but a 2-propanone. 2-propanone we may write. So this is a functional group isomerism. Understand? So this is a position isomerism, it is a functional group isomerism. These two are a part of structural isomerism. One more isomerism we are going to discuss, that is metamerism. Next, fourth type is metamerism. Metamerism, isomerism. Metamerism, isomerism. Okay, what is metamerism, isomerism means? to the functional group. Organic compound having same molecular formula. To the functional group, different alkyl groups are attached. Organic compound having same molecular formula, different functional groups are attached to the functional group. Different alkyl groups are attached to the functional group are called metamerism, isomerism. Okay, see here, organic compounds having same molecular formula but different in alkyl groups attached to the functional group. Different in alkyl groups attached to the functional group. This phenomenon is called metamerism. This phenomenon is called metamerism, and compounds are called metamers. Okay, for example, C4H10O. C4H10O, it is the molecular formula. So by using this molecular formula, I am going to write a compound structure. CH3CH2O, CH2 and CH3. So here it is a ether. It is a ether functional group. Functional group is ether. Okay, it is ethyl. Here attached alkyl groups is ethyl. It is ethyl. Okay, this is nothing but ethoxyethane. It is nothing but ethoxy. So it is the numbering. So 1 ethoxy, 1 ethoxy ethane. It is a substituent. It is a main chain. First carbon containing ethyl plus oxy, ethoxy and ethane. Or diethyl ether. Common name is diethyl ether. Okay, it is IUPAC name, it is a common name. Next I am going to change alkyl groups. Okay, see here, this CH2 group I am attaching this side. CH3O, CH2, CH2 and CH3. It is a methyl group. It is a methyl group. It is a propyl group. It is a propyl group. So we have to write its name. 1, 2, 3. Then it is a substituent. 1 methoxy propane. Its name is 1 methoxy propane. Okay, it is a IUPAC name. It is IUPAC name. General name is methyl propyl ether. methyl propyl ether. Okay, so this is the way. Here alkyl group, ethyl groups are attached. Here methyl propyl groups are attached. It is metamerism. These are the types of structural isomerism. How many types of structural isomerism we have? Chain, position, functional and metamerism. Okay, so structural isomerism is finished. So in previous class we discussed chain isomerism. In this class we discussed first position, next functional group, next metamerism. Okay students, so thank you.